All right, hey everyone. So today we're going to talk about linked lists. So it's really fun, like one of my favorite topics. So we're going to go over some basic implementations of the linked list, some enhancements that you've learned about in class, as well as some scenarios. But you will see the implications of the enhancements. Yeah, so that's like the main purpose or like the main goal for today, just like getting some review in about linked lists. All right, so let's jump straight into it. So the vanilla implementation of linked list, as I always call it, or just as other people call it, the basic linked list, is a node with an item object or an item variable and a next variable, right? So the next variable is a pointer, actually. It points to another node, points to another node. And if you're at the end of the list, then this next variable will contain null. And the object is being held in the item variable. In this situation, it's a string. And when we talk about int lists, normally we are referring to this implementation, but instead of a string, we have item holding an integer, right? So just the most basic vanilla implementation of a list. All right, and then there are obviously some like drawbacks, like having this kind of implementation. I'm sure that in lab, you've encountered many of those. So that's why we have to start thinking about making it more efficient or making it more convenient for us to work with lists, right? Because as you remember from like 61A, we never like bothered you with the implementation of the list because all the enhancements are already abstracted away from you, right? So the first and foremost, like the most important enhancement of this linked list here is trying to create an encapsulation, right? Trying to abstract it away from the user. So instead of just having a node class, right, this list node is an instance of the list node class, we can just create a whole list class. And then we put the node class as a private variable or a private class inside the list class, right? So we're encapsulating it in a class. And this allows us to, like not having to worry about the implementation. You don't have to worry about, okay, if I want to remove a node, I don't have to do p.next equals null or something, right? Instead, here you just implement the functions, remove, get, add, and size. You like implement it in a class, and you don't have to worry about the nodes. And obviously, within this class, there are a lot of different implementations as well, many of which we are going to discuss later. But yeah, you remember like the head, the tail, the size, et cetera, right? So creating abstraction barrier so you don't have to worry about it. All right, the second enhancement that we talked about in class was the sentinel. So the sentinel, right? That's basically just a dummy node that wraps around. Obviously, you have like many implementations of this, but I'm gonna talk about the circular sentinel, right? So the goal of a sentinel is to prevent you from handling null errors. I know it's really annoying. So if we look at this example here, we have list P, item 1, item 2, next, right? And if we want to do p.next is null. So if we want to do something with this, for example, if we want to get the item of this, p.next, that item, then we're going to get that really annoying null exception error that we've had before. Sorry, so this is null. This item is a null, and if you want to get the item of that, then you get some really annoying null exception error, which is really, it just like bugs your code, right? But what if instead we had a dummy node? So in this implementation, we have a sentinel pointing to the sentinel itself, right? So this is a pointer to our dummy node, item 99999. So make sure that you never, ever access the item within the sentinel. You can set this to null, you can set it to whatever, but it doesn't have any value. So make sure that you never access this item here. All right. And now we have a whole list, right? Like we have a whole implementation of this. So if we do .next item, then we do access it, but you don't get any annoying error. So we fixed that. Perfect. Something that I wanted to add is that there are different implementations of the sentinel. Sometimes you have one that doesn't wrap around. And in the latter, like in some situations, you have two sentinels, which is going to be really useful in the enhancement that I'm going to discuss one after this, the doubly linked lists. The purpose is the same, and I feel like if you understand that, if you have a circular one, you also can have two sentinels. That's just a different implementation of the same concept. All right. Then we're going to talk about doubly linked list. And I think one of the main arguments is that it will make your list a lot more efficient. Or rather, I think it's better to say that it makes a lot of functions that you implement with you on your list a lot more efficient. So let's diverge a little and let's start thinking about one of the topics that was being brought up during the quiz, and I think is also in scope for the midterm. Only for this part, you only need to know you need to be familiar with the terms, so linear and constant time. Whereas in midterm 2, you're going to do this more formally. But okay, what is the difference between linear and constant time, right? So O of n and O of 1. How I always compare constant time is that irrespective, or like how defined constant time is, irrespective, like this is like the formal definition, irrespective of how big your input list is, the function that you're trying to apply on that list does not, like the amount of work that it has to do does not depend on how long your list is. So let that sink a little bit. If you have a function, if you have a list, for example, if you want to add a last item to it, you can just add it to the end, right? So that doesn't really take a long time, given that you have access to the tail. Whereas linear time, that means that the amount of work that you have to do increases linearly with the input size of your list. And if you're still a little like iffy about it, then I'm gonna go over some examples so it makes like a lot more sense. But yes, those are like two informal definitions that really help me conceptualize it. Yeah. So for example, if we had these two implementations, one is the singly linked list, this is the doubly linked list, right? And remove last removes the last item. Okay. Um, let's make this item 0 to make it a little more consistent. All right. So you've had until. If you want to remove the last item, right, then first you need to go to tail and you want to get rid of this item. So our goal is to make next null to create a crosshair. But the only way to get rid of this item is to do that, we have to go through the front of the list. For example, if your list was 999 items long, then you couldn't access it through the tail, right? Because tail only access the last item. And you only want to change this. So you have to go through the whole list 999 times. When you're at the last item, you have to get rid of that. So, and now Java garbage collector comes and gets rid of this, right? And then you change your pointer to point to this item, right? So that is linear for the SL list. All right, if we consider the second situation, right, I promise you that some functions are more efficient if we do it, if we implement the doubly linked list. Then we see here that, if a head and points here. So we want to get rid of this one, right? We want to get rid of this item. So if this was 999 items long, you can access this, but you can move back and forth depending, or you can just move back and forth if you want to remove the last item, right? If you want to remove the last item, you can just, this pointer points back and we don't have that problem that we had here. So you can just remove the pointers in constant time. So irrespective of how many items you have, you can just do that. All right, and you would just need to change the pointers here a little bit, which is, let me see. So it'll go here. And then these two would be pointing here. So this would be constant time. For the doubly linked list. All right. The last implementation or the last enhancement that you learned about was the generic list, right? So array deck, if you remember array deck T can be any object. By making this, we don't have to worry about creating a list that is specific to one item. You wouldn't have to be able, you don't have to like create a class for string lists, and then you would have to create like a separate class for like integer lists and et cetera, right? So by implementing the generic like type, you can just create a list for everything. Yeah. So the last thing that I wanted to go over is destructive versus non-destructive. And in short, destructive, if you are asked to implement a destructive function, most of the times you're working with a void function. So you are only making changes to the list that is being put in as an input. You're making changes to it. You're not returning a new list. Versus non-destructive, if you get um, an argument which is a list, then most of the time you want to return a new list. You don't want to make any changes to it. Like you want to make any changes to that list that is being put in. So make sure that if you encounter one of these terms, most of the time they have very different implementations for the same function. So make sure you are very aware of the two differences of those, right? So when you see destructive, a bell has to ring in your head and be like, okay, I'm gonna work with like mutative like functions. Whereas if you see non-destructive, immediately think about, oh, I have to make a new node. I have to make a new list, right? So that was the quick overview for linked lists. Yeah. All right. Thank you for dropping by, and good luck with studying.